So we have a situation like this where the two equal or identical charges with mass 5.20 grams are tied with a string, a non-conducting string, with each of them with length 1.23 meters. A variation of this question is when they are giving you the total length. So pay attention to the wording on the question, if it is each length is or total length is given. So in this case, you have the each length. In the explanation, you have the total length, and on the videos, you have both cases. So now, and as a result of this, what is happening, the two charges that are identical, so same nature, are in equilibrium at an angle theta that is, let's suppose, 8.50 degrees. Again, a variation of this question is when instead of angle theta, that is the angle with the vertical, actually we'll do angle alpha here, so that we just did one with vertical. Let's do this with the whole thing. So angle alpha is, let's suppose, 16 degrees. So when the whole angle is given, and the variation may be that you have just the angle with the vertical, but when the whole angle is given, then in order to find angle theta, you divide angle alpha by 2, and this will be 8 degrees. So pay attention to the wording. If it is the total length, so you divide it by 2, and if it is the angle created between the strings, then to work with the free body diagram and geometry, just find or divide that angle by 2. What we will find here is the charge that each of those spheres has. So always when you have a problem, this being in physics, sciences, chemistry, or whatever, you will start with, how can I calculate the charge? So you don't think 10 steps ahead, but you think, what is the first step that I have to take to solve this problem? And what do we know in terms of the charges is that the one that connects the charges is the electrostatic force between those two charges, which means that you are applying Coulomb's law. So Coulomb's law is Q1, Q2 over R squared. So the two charges, since they are identical, we can say that is Q times Q over R squared. Or Q times Q is when one quantity is multiplied by itself, you can express it as Q squared over R squared. So on this relationship, we don't know, besides the constant, we don't know anything else. However, the distance R is between the two charges is this distance here. Okay, now, can we find this distance using geometry? And the answer is yes. How can we find this? The distance between the two charges can be found in two ways, and you use whatever way is most, it's the easiest for you. Method one, to find the distance, is when we are using cosine law. So you have a situation like this. When you know that angle alpha is 16 degrees, and the length L is the same, 1.23 meters. So in order to find this one here, you can apply cosine's law. Cosine's law, and just for simplicity, I will just put this BC, and it's, you have it in your formula sheet. A squared is equal to b squared plus c squared minus 2bc times cosine A, which means that in our case will be bc squared, which actually is the distance between the two charges squared, is equal to 1.23 squared plus 1.23 squared minus 2 times 1.23 times 1.23 times cosine 16. Make sure that the mode of your calculator is on degrees, and plot this expression in your calculator, so you will find that r squared is value 0.117 and then continues with 2 meters squared. Now, the simple way is to think a step ahead. So we found r squared, and actually we are looking for r squared. So you can leave it like this. But if you want to find the distance, if the question is asking you to find the distance, which in physics will not be, then you will square root the 0.1172 meters squared. However, as I said, since to make our life a bit easier, then we will leave it as r squared. So this is the first way to approach on finding the distance between the two charges. The second method is when we consider the right angle triangle. So method 2, and we are still in finding the distance between the two charges. So method 2 is when we consider the right angle triangle. So we kind of divide that triangle into 2, and then we have here that angle theta is equal to 8 degrees, and this length is 1.23 meters, and we find this, that actually is the distance divided by 2, or half of the distance, since we are dealing with a symmetrical situation. So we can say that sine of 8 degrees using sine ratio, because we have the opposite and adjacent, is distance over 2, between the two charges over 2, over hypotenuse, that is 1.23. And then distance over 2 is equal to 1.23 times sine 8 degrees, or the distance is 2 times 1.23 times sine 8 degrees. Which method you are using, it doesn't really matter, because you should have for r something. R is 0.3423 meters, which even if you square root this value that you have here, you should have 0.3423 meters. So when you square up this, you will have 0.1172 meters squared, and I'm squaring it up because this is the value that we will use to calculate the force. So now, as I said, like, we start looking for what the question is giving, and then we go backward into how can we find this? How can we find this? How can we find this? Okay. So now in this relation, we found what is the distance. We know what is the Coulomb's constant, because it is from the data table, and we still don't know, or we don't know how to yet find the charge that those two identical spheres have. However, from the previous example that we did, we were able to figure out what is the electrostatic force. So now, if we are thinking that if I know what is the magnitude of the electrostatic force, then yes, I can find out what is the charge of each of those spheres. So again, the key word here is that the charges are in equilibrium, which means that you will see, draw the free body diagram, knowing that the force net is equal to 0. Since the previous example was a charge being tilted toward the left, I will do the free body diagram of a charge tilted toward the right. Which charge do you use doesn't really matter. Left or right doesn't really matter. But if we are considering the free body diagram of the charge that is on the right, then we will have the universal force of gravity that is always going toward the center of the Earth and is with magnitude mass times acceleration due to gravity. And then we will have force of tension that is always starting from the object going along the line with forming an angle with a horizontal, as we know, 8 degrees. And therefore, what do we have here for the electrostatic force is a force that will cancel the horizontal component of the tension. And since the horizontal component of the tension is toward west, the electrostatic force will be toward east. Now, this is a 2D situation, which means that the easiest, the most structured way is to build the table of component, horizontal, vertical, force of gravity, tension, electrostatic force, and force net. Since the two spheres are in equilibrium, equilibrium means that force net is equal to 0, which makes us draw the conclusion that even the components will be equal to 0. And then we complete the table. So the table of component will be something like this. And then from here, we can draw that. From the horizontal component, we will have the equation T, or positive T, cosine 8 degrees plus Fe is equal to 0. Actually, this is negative T, because it is going toward east, sorry, west. And from the vertical component, we will have negative 0.051012 minus T sine 8 degrees is equal to 0. So you have now a system with two variables, T and Fe, and two equations. You start solving it using the vertical. Why? Because the vertical has one variable on it. So then from here, you can say that T is equal to, this is positive. I'm losing it. Is 0.051012 over sine 8. And then we take this value and substitute it on the second one to find the electrostatic. 0.367 Newton if we consider the rounding. And then we take this value and we substitute it into the other equation. And then we will have negative 0.367 times cosine 8 degrees plus Fe is equal to 0. From here, the electrostatic force will be equals to times cosine 8, 0.3701, but it doesn't really matter, newtons. So now, in that relationship that we had, that we started with, that Fe is equal to Kq squared over R squared. Now we do know what is the electrostatic force, is 0.3701. We do know what is a Coulomb's constant from the data booklet. We figured out what is R squared or just R, and we are looking for Q squared. Let's see now how we can manipulate and have literal formula, so that even if you have like a question that is asking you for the charge, you can figure it out. So in a literal equation, what do you have is you solve for whatever you are looking for, in this case for Q, assuming that everything else is known. You know what is the value. You don't know what is the specific value, but you will assume that will be a value. So the first step here is to multiply both sides by R squared, because we want to get rid of the denominator. So you will have R squared times Fe is equal to KQ squared. Now, when you are solving for something, it doesn't matter what it is. It's like the variable that you are looking for to solve is screaming at you, leave me alone. I don't want to be with anyone. So, and you leave alone, quote unquote, a variable by canceling out everything that this variable is associated with. Multiplying, canceling out will be dividing. Dividing, canceling out will be multiplying. This is what we did for R squared. Square up will be the opposite, or the opposite of squaring up is square root. So in this case, we'll divide both by K, and then we will have Q squared is equal to R squared times Fe over K. And now the square root is the opposite operation of squaring up. So you square root both sides, and then you will have Q is equal to the square root of R squared times Fe over K. You can take away from the square root the R squared. However, since if you are using the first method, the cosine law method, to find R squared, leave it there. Don't worry. If you are finding the right triangle, then take it away. So it will be R and then the square root of Fe over K. And so if you are using cosine method, use this formula. If you are using the right angle triangle, use this formula here. In our case, Q will be the square root of 0.1172, I think it was, times the electrostatic force that we just found is 0.3701. 0.3701 over K, that is 8.99 times 10 to the power of 9. And then we square root everything. If you are using the right triangle method, then use this formula, and then you will have a substitution like this. KR is 0.3423. So 0.3423, and then the square root of 0.3701 over 8.99 times 10 to the power of 9. Whatever method you use, you can you still will have the same result. The final answer will be 2.20 times 10 to the power of -6 coulombs, and those two charges are the same. So the magnitude of each charge is 2.20 times 10 to the power of -6.